as you look at different kinds of power sources, some of these can actually be added together in the form of what we call series aiding voltage sources. In this first example, I have 3 volts. This is a 3-volt battery. This is a 6-volt battery down here. And to get a total amount of voltage, we take the 3 plus 6, because they're series aiding, plus minus, add those together, and we wind up with 9 volts. As we look at the 2 terminals out here from this voltage source, they're actually going to be a 9-volt source that's going to look like this. This part down here we're going to talk about later. It's going to be connected to a ground or other type of connection on the circuit. And this is our main power output right here, 9 volts. So between these 2 points right here, we have 9 volts. Let's see what would happen if we turn some things around and see what we would get in that case. Let's take this voltage source that I had at 6 volt, and we're going to turn it around, and we're going to make the series opposing. In this particular case, we see that this is the positive terminal of the 3-volt battery, the negative terminal of the 3-volt battery, the negative terminal of the 6-volt battery, and the positive is right here. Now this presents kind of an odd situation. As you're looking at it, you kind of wonder, well, how would you have that? Different types of electronic circuits actually do have dual polarity type power supplies. Many operational amplifiers use these. So in the case of what we're working with here, we have 2 types of batteries. They were the same as before, only I turned the 6 volt and flipped it around so that a minus terminal from the 6 volt connects here. This makes what's known as minus to minus is actually going to be series opposing in the voltages. So as we're looking at this, we're kind of wondering, well, how would this actually look and what would be plus and minus? Now up here we do have a positive source, but this is a smaller voltage. And the case down here, this is a positive particular source, and this is actually going to be 6 volts here, but this is a little higher. So with regard to looking at this versus this one, we're going to have to take this 3, which is the smaller, and subtract it from the 6 volts. We now are going to wind up with 3 volts appearing out here at these 2 terminals. Even though this is series opposing, is still included in this particular circuit. Most of the time you would usually take this center and run it to a ground, which is a common current point we're going to talk about later. And in this particular case then, most of the reference would go right here to this point, which would be 0 volts. Then you would have plus 6 volts this way and plus 3 volts coming out here. As it is, if you put a voltmeter out across these 2 terminals, this is what you're going to read. Here's our voltmeter. We've tied it into these 2. So what this is going to read is this is going to be 3 volts, but this is going to become the positive terminal, and this will actually be the negative terminal. Because this voltage source is only 3 volts, this is much bigger, 6 volt, it's going to be the leading source of power for this particular power source. 6 volts here is positive terminal, that would be positive here. 3 volts was subtracted from this winds up being almost a cancellation, which means that 6 minus 3 leaves you with 3 volts. This meter should weigh 3 volts, with this being the negative terminal, even though it's tied to positive. This one, being the higher positive terminal, becomes the positive part of this power supply.